There ain't anybody giving database access to a marketer, so I'm out of this one.
You're just not trying hard enough, Tony. Go and delete something so you've got a story.
Welcome to Continuous Delivery Office Hours, where we delve into the topic of modern software delivery. I am your host, Tony Kelly, and I'm joined by our regulars, Mr. Bob Walker and Mr. Steve Fenton. The big question that we're going to answer this week is, drumroll, how do I manage database changes? And that's probably a broad question to start with. And I suppose the thing that pops to mind for me, if we want to start here, is why is managing database changes fundamentally different from managing application code changes, or is it?
Yeah, so I would absolutely say it is different. And the reason why I say it's different is because, I mean, really, you only have one copy of your production database, and it is production. And if there's any sort of problems or if there's any sort of downtime, that's just not acceptable. You also could end up in a situation where it's data loss. And so the concept of, say, rolling back is not really safe without having some sort of data loss. And I think that's a common misconception of like, oh, I can just easily roll back. Like you can roll back your application, but you can't roll back your database, especially if customers or users have started using the new changes. Let's say you added a new column or you added a new table, and then you'd say, "Oh my gosh, I need to roll back this application change," but I've had it live for 20 minutes, 30 minutes, and I've had users in the system adding data into that table. Well, what do you do? Do you just leave it there? Do you delete it? Or it gets even worse if you start making database refactoring. So yes, it is. It's very much it's a complex thing, especially if data loss is not an acceptable answer. And I would say for the 99% of the people that we talk to, I would say data loss is not an acceptable answer.
I think it's worth adding as well that the reason this is so important is because even teams that have got quite advanced on their application deployments very often haven't got sophisticated with the database deployments. So this can be a major problem because effectively, I mean, the DORA research kind of highlights this. Database change management is one of those capabilities that helps you perform better. And I kind of feel that we sometimes have all of these controls around the way an application goes from like a change on my machine all the way through to production. It's quite disciplined. But then the database changes are a lot more kind of folksy and handcrafted, and that's causing big problems with databases. That approach doesn't scale, and even at a small scale, it's not a safe way of managing a database. So you'll often find teams where the production database and the staging database are not at all the same thing. They're completely different schemas, different indexes, a complete mess basically.
Yeah, and there's a couple of things that I always think about when you don't automate your database deployments, when you don't have that as part of your whole process for how you deploy out to production. It's a lot like you have a Ferrari to get all of your application changes to production, but then you fill it with, say, the cheapest, 60 octane gasoline you could possibly fill it with, and you get all these knocks and bumps because it ends up being like the worst possible experience. Like, yeah, I have this really great car, but it doesn't go very fast because of all these other things that I do. I can't tell you the number of times that the actual code change deployment took us, say, 3 minutes, 5 minutes, if that. And the database change, because it was manual, because it was the first time we ran it, because it was so error prone, that's what made the deployments last 2, 3 hours. It wasn't the code, it was the database because of the fact you can't easily roll back and you have all these scripts. On top of that, to your point, Steve, like distinctly remember I was working on an application that we had dev, test, stage, prod, and every single schema for the same database was different per environment. Uh, and it's like, well, is this going to work? I don't know. And so we were always generating the delta scripts, the comparison scripts. We were just comparing between, say, test and staging or staging and production. And it was the first time we ran that script is when we went to production. Like, well, I hope this works.
Yeah, it's quite scary, and I think it's very often there'll be like maybe someone's trying out some kind of schema change, and so it gets maybe to their dev database and maybe to their test database, and then they realize that's not going to work, so they kind of go back to the drawing board, but then that's not being undone, so you end up with this drift. And then there's cases where maybe there's a problem in production, and you use a tool and it suggests an index, and so you apply the index and that solves the problem, and you're like, well, you haven't flowed that back to the other environments, so there's another bit of drift there. And it reminds me quite a lot of traditional ops versus more modern infrastructure as code type ops, where just that drift, even over the course of a couple of months, actually becomes a major problem.
And we're just talking. Imagine anyone who's watching this, you might be thinking just at your individual application level. I ran into the exact same thing. Actually, believe it or not, database automation was the very first thing that cut my teeth in terms of automation for deployments. It wasn't code deployments; it was the database deployment, because that was the problem that we needed to solve. It was a DBA. His name is John. That was working at the company I was working at, and it was basically, as he said, it was the Wild West. Anything could go, anything could happen. Every team was deploying differently. Some teams, they would put all of this change scripts in a folder, and they'd have some sort of like master control script. Other teams, they just had one massive script, and there's just no rhyme or reason. And the DBAs, they're losing their mind because they're the only people that actually have the permission to run the script in production. And they're getting these change scripts. They're like, well, have you tested this? Have you ran it? And it's like, no. It's like, oh my gosh, like, is this going to work? Like, we'll find out together. And so this wasn't a sustainable thing, because we had 10 plus teams, 100 plus developers, and we're trying to do more and more deployments. I think by that particular point in time, we had I want to say at least 2 deployments per night during the week, and then like every couple weekends there was a deployment, and it was just a total disaster. And so when you start thinking about these problems at scale, that's when you really start noticing all of the problems when it comes to the database management and not having the automation. And so that's kind of where I came in. I was the lead dev on the team that they approached for, hey, we want to solve this problem in your application that you're working on is the most complex. So if it works for you, it's going to work for everybody else. It's going to eliminate all of the, well, it's not going to work for me pushback. And so that's kind of how I got involved. And so I was kind of focused more on the application team side and the smaller micro point of view. But the DBA that was working with us, John, he was very much concerned at the macro level of how can we scale this out to everybody else.
To take that a little bit further, Bob, what in that scenario, what does good look like from the perspective of database change management done right? Like what would that be if we could wave a magic wand and say this is the path to follow?
There's 2 things that I think are absolutely critical. The first thing is you have to get your database change scripts into version control. That is absolutely paramount no matter what you do. Now, there's 2 schools of thought behind it, and we can have Steve and I, we can have a deeper discussion around state-based versus migration-based. But regardless of your approach, that has to be in version control, ideally alongside your database. Ideally alongside your code. The other massive change that everyone has to make is you have to start with a local database on your developer machine, because all too often everyone has a shared development database. And that's kind of the first big change for people is, oh, now I have to run a database locally. It's like, yeah, you run the code locally. Why wouldn't you run the database locally? And the reason behind this is because, to Steve's point, as he was talking just a little bit ago, well, I want to test out this schema change, or I want to test out this index. I want to test out this one particular thing. And if it doesn't work, hey, not a big deal. You have only impacted yourself. You've impacted nobody else. And by having a local database, it also guarantees that you can start having the exact same schema between dev, test, staging, production, or however many different environments that you have, because that's absolutely critical as well. So you have to eliminate all the drift between all of your environments. I think the only thing that's allowed in terms of my mind, in terms of drift differences, is what's about to go to production and who has permissions to do the thing. So you have all the roles, but then the people that are assigned to the roles, that's the thing that's different. That's the only delta that you can have, but everything else should be the exact same. That way, there's no surprises in terms of the schema. Now, the data obviously is be very different, but in terms of the schema. Steve, I don't know if you had any other thoughts you wanted to add to that.
Yeah, I think probably the next step on that is once you're in version control, you need some tooling around it that helps you manage applying the scripts in order. Ideally, it helps you apply scripts only once, because I've seen quite a lot of database automation where what was checked into version control was just like all of the SQL scripts that do schema upgrades or all of the kind of like changes. And sometimes they kind of get out of order because people are committing things at different times, or you have all these issues with someone trying to make it so that this giant script will run, and you end up with problems of someone committing a script that doesn't check to see if the change has been made or not, right? And so if that runs multiple times, things kind of like the database script errors. There's a lot of kind of subtle trip hazards if you try and roll your own database upgrades.
And so I typically see what for like starting out, it's more of a state-based management because that's probably the easiest, which is I want the desired state of the database, and that's what's stored in version control. And then the tooling, that's the thing that's going to manage that desired state. So it goes, okay, you want all these tables, you got it, boss. I'm going to make sure that you have all these tables, and it's going to match exactly what you have. And I think that's a really good way to get started because it kind of gets you familiar with one, getting your database changes into version control. Two, working with a tool that manages all of this and orchestrating it from your deployment tool, getting familiar with that. And then three, finally, kind of working through all of the sharp edges that is database automation for the first time. But then eventually you start noticing all the sharp edges with that approach, doing things like, oh, I want to move a column from table A to table B. Well, if you just do that and locally in your, and then you have say, okay, I want to do a state-based approach. Well, it's going to delete the column from table A and add the column to table B, but it's not going to do anything with the data. And you're like, well, that's not what I wanted you to do. I just lost a whole bunch of data. This isn't going to work for me. And those are common things that typically happen. And that's a very simplistic example, but there are a lot of other examples I remember running into. And so then that's when you kind of graduate to migration-based approaches, where it's okay, started with state-based, now I'm going to go with migration-based, and that's how I'm going to go from now on. Even with brand new projects, I'm going to do a migration-based approach where I'm going to have a series of scripts in order. I'm going to run it, make sure they run in order as appropriate. So you might have a script that adds the table, and then the next script would say add a column to the table, and that might come weeks later as you're iterating.
How does Octopus fit into this? Because there's specific database tools and platforms that are just, they're the database things. If we look at it from an internal perspective of Octopus, where does it sit in helping us do this better?
Yeah, so there's a couple ways that we help out. The first thing is we will integrate with those tools. So, for example, Redgate was the first tool that we integrated with in terms of database change management. And now we have integrations with Flyway, which is owned by Redgate, also Liquibase, and there are a number of other tools out there. So what we do is we'll orchestrate it. But one of the other things that we can definitely do is oftentimes these tools have the capability to do dry runs where they will generate a Delta report as to what's going to change, or either what scripts are going to change, or the exact the names of the scripts that are going to run, or something. It's going to generate some sort of report. And then from there, you can do a couple of things. You can have some automation that will look for some dangerous commands, such as like drop database or delete table that you'd really want to know about. Uh, and we could pause it for a manual intervention and have a DBA review it and say, hey, this has some dangerous SQL in there. Let's take a look at it. Let's make sure that it looks good. Um, or you could just skip all of that, not have the automation maybe you just start out with, and you generate the Delta report, and then you have a certain environment, say staging. And that's when you have a DBA or you have somebody else like a database developer, someone who has that subject matter expert. They can review what's about to go up. And in addition to that, we can also store that Delta script as a deployment artifact as part of Octopus. And so you can see that, you get that history behind it. And then finally, we actually do the orchestration. So there's actually within my within Platform Hub, I have a process template that does database deployments, and it has those 4 steps. It's generate the Delta report, check for auto approval. If I see something wrong, then it will ask the DBA to review. In addition, I'll also look for meaningful changes. Were there actually any meaningful changes for me to run? If there's not, then skip the step that's going to do the deployment because it doesn't make any sense. Like there's no reason for me to run something that's not going to do anything. So there's a lot of different ways that we can integrate. And so, yes, we're not a database deployment automation tool, but we integrate with it and we can perform a lot of different actions and deterministic processes that can ultimately make it a much better overall experience.
And crucially, we can reduce the need for you to give people access to the database. So if all of your database upgrades happen through Octopus as your deployment tool, you don't need someone to take a script and paste it in somewhere. And you don't need to give people permissions to do that. And you can also stop the need for like testers to raise a ticket to say, can we upgrade the test database now? Because I want to test that new version, because that can happen. You know, you've got role-based access controls. Testers can push the updates to their test environment, but they won't be able to push to production. And then the people that can push production don't necessarily need to have like SQL permissions to actually directly operate against the database. There are so many subtle errors that you can make when you're loading up a script and running it in like a database management tool. For example, this is just a list of things I've done. You can log on to the wrong database server.
Yep, done that.
Everyone's done this.
Yeah.
Or you can log into the right server, but select the wrong database from the list of databases that are on that server, right? So there's all these horrible things that can happen that can cost you hours of remediation time of like, how do I remove this, this change from the database I didn't mean to apply it to? And that takes time, whichever environment you've made that mistake in. You know, hopefully our mistakes will happen not in a live environment. But yeah, it can be a bit of a disaster.
In addition to that, speaking of the testers, we also have runbooks. And so there's a lot of tools that is out there that will allow you to do things like take a database backup, apply a whole bunch of rules that will remove a bunch of personally identifiable data from that, even that production backup, and then you could restore it to say a developer's machine or to a shared test database for the QA people to hit against, or to maybe a staging database, so you could have some, your business analysts or your business owners, they could review it, or you could have some, some beta testers that would want to get in there just to try it out. Any number of those different things. You can have a run book that automates all of that for you. Or you can even go even farther, which is sometimes the solution to a problem in production is you just have to run a SQL script. And it's not to add an index, but sometimes it's just data gets in a weird state and you just need to run a script that updates one row in one column and it just fixes the problem. And you're like, I know there's a better fix for this, but the customer's blocked, the user's blocked, whatever the case may be. All right, let's just run this. And I know that, that's not an ideal solution, but it is what it is. And so you can also automate that with runbooks as well as even a process template. So you could have a runbook per application that fixes that. And then the process template, it can go through and it can do things like, I'm going to run this script against a transaction and see how many rows it's going to change. Oh, it only changed one row. Okay, this passes it. I don't see any dangerous commands. I just see update or insert into or select. Okay, great. Have fun. There's a where clause. Those types of things. It looks for those types of things. And then if everything passes muster, it can just automatically run it. But if it doesn't pass muster, you could have someone pause and maybe have your database developer review it, your lead developer review it, a DBA review it. But you're not giving access to production per se. Everything is running through this script. And so there's a whole host of runbook automation that you can do in addition to doing the actual database deployment that makes it so much easier to manage. And you don't have to give that access to people who don't know what they're doing, or giving too much access so you can accidentally run the wrong thing. I can't tell you the number of times that I've talked to somebody and they thought they were connected to, say, the production copy, N-1 production copy, and they're running scripts on it. Like, no, they actually ran it on production. And it's not even a insert statement or an update statement. It's a really expensive select query. And it just consumed a whole bunch of resources, and they didn't set it to the transaction read uncommitted. And so it locked the entire table. So there's a lot of those little, like to Steve, what Steve said, there's a lot of these little subtle things that you could accidentally do, even with a select statement, that can cause all kinds of havoc. And by doing this, you can really restrict who can and can't even access the databases and put everything through Octopus and have everything controlled via RBAC controls and have it be very controlled as to what they can do. Okay, you can log on to the SQL server via a runbook and you can do this one particular thing and that's it. You can't run whatever SQL statement you want to run.
Yeah, I think you mentioned test data there, and I'm allowed to mention DORA reports 3 times. This is going to be my second one in this call. The test data management is one of the capabilities that they mentioned in the DORA report. And one of the things that I've done in the past is I've made sure that my integration tests only depend on data that is being put in as part of the deployment to like the integration test environment. So you never have that problem of trying to run an integration test, but someone's touched the customer that you're looking at or some of the data, and now you're failing because the data's moved. So as part of the deployment, every time we reset that staging test data, and we had like a reserved range of known IDs that we were using for test data. So we could technically we could put that into any environment if we wanted to, and we would never touch like a real customer. And yeah, just like that just removes a whole class of problems that stop you from having great tests because you always get reset to a baseline before a test run. You know, it's like it just gives you a stable base for that automation, and stops flaky kind of flip flop tests.
I would also say it's more than just the integration testing. It's also part of the developer experience. If you can have that process that can do it for an integration test database that builds in, sorry, yeah, rebuilds it and then destroys it and rebuilds it and destroys it. That's something you can also do for your local database. And that was absolutely one of the key roadblocks for local database development was there's no data for us to test against. And so, yeah, I can connect to it in happy days, but until we provided the capability where you could create this test data locally, um, everyone was still pointing to the shared test SQL server because they needed the data locally to actually run the code and verify that it's working. An even better approach in my mind is also having the capability to take a clone of a particular environment in terms of a specific record or specific like set of records. So for example, I worked on a loan origination system and we had the capability to pull down from our test database down locally and we basically walk the entire spider web of all the dependencies and pull everything in and then be able to copy that in locally. And that was super helpful because if QA ran into a bug, we could just clone it down, step through the code, find the bug, and then we're on our way. So all of these different things is absolutely critical. But yeah, the testing data is another big piece that I think that people typically will overlook. And if you have this sheer just kind of momentum of this is how we've always done it, this is how it's always worked for us, and I'm just going to have this shared database that everyone goes against, it's too easy to fall into that rut. So there's a lot of different things that you kind of have to address.
Yeah, and automation's crucial there again because if you're cloning data down, you often want to anonymize fields in there. Like you'll replace all of the email addresses, right? And you'll replace all of the phone numbers, and you'll go through and you'll just kind of anonymize all those records so that your test server isn't going to email a real person, isn't going to phone a real person. Now, if you haven't automated it, there'll probably be a step that says now run this script that will do that. But someone could forget that, and then it's going to be a really embarrassing headline. So this is why automation is so important to databases because it needs to be really repeatable, reliable. You know, it's just such a crucial thing with databases.
Yeah, and the nice thing is when it comes to a lot of that test data, there are tools out there that will allow you to do that. So for example, I know Redgate, they produced a tool that will create a test database from an actual production database, and it runs all of the scripting to anonymize appropriately and remove all the PII information. And in some cases, it'll actually insert in kind of I wouldn't say dummy data, but data that represents. So instead of, first name, last name is Bob Walker, it would replace it with John Smith. And then the address replaces with 12345 Test Street. and the email address is replaced. Instead of just this random bunch of strings, it's actually like test@example.com, for example. That's to give you an idea of some of the things. And so that's one of the advantages, I suppose, of when you purchase a tool, is it kind of get a lot of those things. Now, the advantage with Octopus is then we can integrate with that tool and bring that down, and you'll be able to repeatedly run that either via runbook or as part of your deployment process.
I think my final question on this would be, if somebody's listening and they're like, yeah, I want to start cleaning up my database change process, where or what would be the first thing you recommend that they look at? Is it getting the local version of your database? Would that be your go-to, or would it be something else?
Yeah, that's an interesting thing. I would think getting your schema into version control is probably going to be the first thing, and identifying the tool that you want to use. And then second step would be getting a local copy so you can actually see if that schema can be applied locally and your application can run locally. Because without that, then it's kind of just a mishmash as to what it can do. And then after that, okay, now that I have it in version control, now that I have local database development, okay, now how can I automate this? How can I run the schema or these schema script changes, in a dev environment automatically using my deployment tool like Octopus? And then from there, I'd say that the next step is, after you figure out how to promote all the way up to production, because you're going to have to fight the dragon that is the political enemy for doing that, especially if there are people that don't want to change, which it's fun. And then after that, I would say, then you start focusing in on the test data and getting that test data in there. And then I would say, then after that, then hopefully there's a lot more. I imagine there's a lot more advanced strategies, like, hey, how can we automate the test data creation? How can we automate all of these other access controls that we used to give developers read access to staging or production, but we don't want to give them that access anymore. Okay, if you do that, what can you do, like with runbooks, or what can you do with these other things to start removing this access piece by piece?
There's a whole bunch of skills that you will need to learn if you haven't automated your database schema changes before, because good database upgrades are backwards compatible.
Yep.
You could upgrade your database and without updating your application, and everything works. And then you should be able to bring your application forward, and everything works. And so that means you have to develop some skills around how you would do operations that would break that principle. So if you're renaming a column, it now needs to be done in a few stages, because you need to add the new column first, make sure that's all fine. Then your application can start depending on that new column. And then you can migrate data. And so there's this whole process. There's a great book called Database Refactoring Patterns that has a whole bunch of techniques that you can use to make sure that you're sensible about how you roll your database and applications forward over time. And it just means you'll never be in a situation where you've got a bug in your application, and you can't redeploy the previous version because the database won't work with it.
The pattern you're describing, if anyone wants to look it up on Google, is called the expand and contract pattern. And there's a lot of literature outside of the book itself. Obviously, the book is going to have a whole bunch of other database refactoring. The other thing I would say is, if you're thinking about doing blue-green deployments or canary-style deployments, or any sort of those progressive zero delivery downtime, if you don't adopt database automation, it doesn't matter. If you have a database backend for your application, you're not going to get there. You're not going to get canary deployments. You're not going to get blue-green deployments, no matter how hard you try, how you get it there. And then to Steve's point, after you do that, you have to adopt the expand and contract pattern, because it's a very deliberate series of steps to make sure that I can run two versions of my application in production at the same time, both pointing to the exact same database. Because without that, you're stuck in the water. You're dead in the water. It's just not going to work. And I think it's the hardest step, I think, to do, honestly, because so many the tools these days, like with Argo rollouts, it's so much easier to do canary style deployments or blue-green style deployments or whatever you want to do. But without the database, it's doesn't matter.
I was thinking we should really start a book club with all these recommendations. There are some fantastic book recommendations every week. So, but Steve, over to you.
Yeah, so question of the week is super easy this week in terms of choosing the question. I don't know how easy it'll be to answer. I am interested in your worst database nightmare story. What's the worst thing you've done with a database in your career?
Oh, that's easy actually. Um, so my team, I approved this change. Uh, they checked in one line of code, and I reviewed the pull request. Go, yeah, absolutely, that's the change you should have made. We increased throughput to our SQL server by 1,800% on the most expensive query that we have, and that SQL server was shared by all of our internal applications, and it crashed everybody in production for about 3 hours, and as all of the internal applications went down because the SQL server couldn't keep up with the volume of queries that were coming in because the data that was trying to process and store into memory, it was basically kicking everybody off just to process all of these things. So that was probably the worst that I've done in terms of the database is increase throughput to the most expensive query possible and bring down an entire production level SQL server. And this wasn't like some rinky-dink 4-core 16 gigabyte one. This was, I think it was like a 32 core 256 gig behemoth. Um, it was quite the sight to behold. The DBAs were quite surprised that that could happen, especially because it was a cluster too.
There ain't anybody giving database access to a marketer, so I'm out of this one.
Well, technically there still are. It's possible to press delete on something in a tool that you don't mean to press delete on, but hopefully there's a way of bringing it back.
I mean, you have access to our snowflakes, so I mean, I'm sure you can cause some havoc in there. But it's just read access, though. I'm not quite sure what you could do.
You're just not trying hard enough, Tony. Go and delete something so you've got a story.
You could really run up the bill on Snowflake.
All things I don't want to do, but I may in the future.
How about you, Steve?
Funnily enough, actually, I'm going to let it be someone else's worst database problem, but there's also a confession. I will use Dave as an example. I always use the name Dave because that way it's safe. But Dave was trying to delete an entry from a giant attribute value table that we had. And we had a database design where this attribute value table could represent like a million different things. So there were lots of different lists in there of properties and settings and all sorts. And he just wanted to delete one of the items in there, but he missed off the where clause.
Yeah, that's what I was just thinking. I bet he forgot the where clause. Yep.
Deleted the entire table of data. Now, we had backups, we had all of the good stuff. And so I sat with him, and we couldn't just restore the database backup because lots of other data was moving at the same time. But it was only this attribute value table, which was reasonably static. So we restored the backup alongside and then copied the data back over. No big deal. I think for 30 minutes, some people were seeing some weird things, and then it all started being good again. But Dave said to me, wow, like you fixed that so calmly and so easily. Like, how did you do it? And I went, well, it's just experience. But the truth is, I was Dave literally about 2 years earlier and did exactly the same thing. So I had the whole playbook of how to recover from it because the developer before me who had rescued me had done the same thing a couple of years before. But it just goes to show that, like, at some point we should have turned around and gone, maybe we shouldn't be doing this in production, given that there's now been 3 separate occasions where we've nuked this table, in exactly the same way.
That also illustrates the dangers of just doing a database backup and a rollback because the rollback itself is a lot more nuanced in that particular case. It's I want to restore a copy of the database alongside the actual production database, and I only want to bring over this one table. And sometimes it might be I only want to bring over this subset of data from this one table. And the thing is like with rollbacks, you don't want to be testing that process in the middle of a crisis because that's the last time that you want to do. You don't want to be like Indiana Jones and Raiders of the Lost Ark. It's like, I don't know, I'm making this up as I go along. That's the last time you want to have that approach.
Yeah, and like you can have full like transactional backups, and technically you can pick at the point in time that includes the transactions you want and before the transactions that were bad, and there's all that kind of stuff. But I've seen various problems caused by that as well. Kind of reasonably tricky. Plus, there are a lot of databases out there that are set to full recovery mode that have never actually been backed up overnight, and so they have these like terabyte-sized log files because they desperately want to be backed up. So if you do have full recovery, make sure you have a maintenance plan.
Consult your local DBA. They are much smarter at this than we are, and they will definitely know how to set that up appropriately. But yeah, this is it's a topic that I think gets skipped over. Oftentimes, I think, just kind of close it up, I think one of the reasons why is because oftentimes the DBAs, the people that are involved with the deployment itself, the people that can run the scripts, they're kind of almost sit off to the side from the regular operations people. And when you talk to I remember attending PASS, for example, and we had a booth there, and people would come up and we'd explain, problems we solved. They go, "Yeah, that's really cool, but I have to get the developers on board to do this first, and then, I'll be happy that we can start doing that." So you have to convince, like, multiple groups of people that this is a problem to solve, and then they all have to agree. The best way I found to actually get traction in here is to have kind of a working group, or kind of a working session, a 2-day working session, where you get representatives from all the key groups. You got your DBAs, you got your DB developers, you have your database, the actual architect of the entire database, you got a lead dev, a QA person, all get into a room together and go, okay, what do we want the process to be? And everyone talks, and they all make sure that they're represented in terms of the process. You can't do that. This is something you can't do in isolation. You can't try to go around the DBA, because you're only going to end up with more workflows and processes. I've tried it; it just doesn't work. And you can't exclude, say, the QA people, because they need the testing data. So all of that needs to be resolved. So that's why I think that you need to have something where you have everyone comes together and they work to solve this particular problem.
Maybe we do need DevOps after all.
Perhaps.
The names change, but the problems are still the same. You can call it DevOps, you can call it platform engineering, you can call it whatever you want to call it. Rose by any other name.
Thank you both very much, folks. Safe travels to KubeCon. If any listeners are lucky enough to be attending KubeCon in Amsterdam next week, keep an eye out for Steve, Bob's talks, demos, keynotes, all of the above, and pop over and say hello.
Thanks, everybody.
Bye-bye.
Bye-bye.